Astronomers may have found a new type of object in the Orion Nebula, a famous stellar nursery. What if I told you that the James Webb Space Telescope just discovered something in space that shouldn't exist? And not just one or two, but multiple structures like this. 6 massive galaxies were recently discovered by NASA using data released from the James Webb Space Telescope. Scientists are confused because they might just need to rewrite the textbooks. Let's take a look at what they have discovered. 1. Massive ancient galaxies ***. 6 bright red spots of light were discovered by the James Webb Space Telescope, and these are no ordinary spots. They are some of the earliest and largest galaxies ever found, dating back up to 13.3 billion years. These 6 spots were so red that they must have formed just a few hundred million years after the Big Bang. From what scientists previously believed, these structures shouldn't have even existed back then. Experts used to think it took a lot longer for the first stars and galaxies to form. In reality, these ancient galaxies were already massive and bustling with star formation just a few hundred million years after the Big Bang. One of these universe-breaking galaxies is 1 trillion times more massive than our Sun and 10 times the size of the Milky Way. This discovery has disrupted many theories because it suggests the universe didn't begin like we thought it did, and the dark ages of the universe may not have been so dark after all. 2. New finds in exoplanet molecules ***. Astronomers have been obsessed with finding exoplanets, and one notable candidate is K2-18b, which might harbor life. This planet has water vapor in its atmosphere, and more recently, the James Webb Space Telescope detected carbon-bearing molecules like methane and carbon dioxide. So yes, K2-18b may have a hydrogen-rich atmosphere and water oceans, perfect conditions for life. But wait, there's even more. The compound dimethyl sulfide, which is produced by living organisms on Earth, has also been detected. It's an exciting possibility that K2-18b could indeed harbor life. 3. Origins of the cosmic web ***. Astronomers using NASA's James Webb Space Telescope spotted 10 galaxies arranged like a string just 830 million years after the Big Bang. This is like finding a childhood picture of the universe. The problem is that these galaxies shouldn't have existed back then, according to current theories. This structure is about 3 million light-years long and is anchored by a super-bright quasar, a galaxy with a giant black hole at its center. This line of galaxies might eventually grow into a huge cluster like the Coma cluster, which we know in our neighborhood of the universe. 4. Early supermassive black holes ***. You probably know that black holes grow in size by consuming stars and clouds of gas and dust. Thanks to James Webb, scientists have now captured supermassive black holes working in the early universe, even when they haven't had much time to feast on their surroundings. In fact, it also captured the most distant black hole ever seen in X-rays, in a galaxy called UHD-1, located 13.2 billion light-years away. This black hole has an estimated mass between 10 million and 100 million times that of the Sun, which is mind-blowing when you consider that it's comparable to the total mass of all the stars in its host galaxy. 5. Hubble Space Telescope's HSE Head Nebula ***. The HSE Head Nebula, also known as Barnard 33, is about 1,300 light-years away. Using the James Webb Telescope's instruments, astronomers have been able to see the small-scale structures of the illuminated edge of the nebula for the first time. The nebula formed from a collapsing interstellar cloud and gets its glow from being illuminated by a nearby hot star. Although the gas clouds around the nebula have mostly dispersed, the iconic pillar shape is made of dense material that is holding tough. Astronomers suspect the HSE Head Nebula has around 5 million years left before it fades away. 6. The dust left by a supernova ***. Then there's Copia A, the aftermath of a star explosion 11,000 light-years away that occurred around 3,140 years ago in the Copia constellation. We can still see its remains today. Astronomers are particularly intrigued by the warm dust, which plays a key role in forming planets and life. Most of this dust comes from the supernova, heavy elements ejected by the explosion. Thanks to James Webb, we can now see the tiny fragments of debris made up of sulfur, oxygen, argon, and neon, all glowing in beautiful orange and pink hues. The dark gaps you see in the image are caused by those tiny fragments piercing through the gas, leaving a cosmic trail of bullet holes. 7. A star-forming region in the Serpens Nebula ***. Serpens Nebula, located about 1,300 light-years from Earth, covers around 16 trillion miles by 11 trillion miles and is where many young stars are taking their first breaths. NASA's James Webb Space Telescope found several unusual things in this nebula. Among the discoveries are aligned protostellar outflows, which are jets of gas expelled by newborn stars interacting with the surrounding gas and dust. These outflows are all aligned in the same direction, which has never been seen before. The telescope also spotted a planetary-forming disk that looks like it's flapping, adding to the wonder of this discovery. Unseen features in the Milky Way's heart ***. James Webb is also revealing more information about our galaxy's center. The telescope's near-infrared camera recently captured the most detailed image of the Sagittarius A region, which is about 300 light-years from the Milky Way's central supermassive black hole. In this image, we can see around 500,000 stars, some of which are associated with mysterious structures that seem to defy known patterns. Astronomers are puzzled by some needle-like structures in ionized hydrogen that appear much bigger than previously thought. There is also a cluster of protostars, stars still in the process of forming and gaining mass. 9. Jumbos in the Orion Nebula ***. In the Orion Nebula, about 1,350 light-years away, the James Webb Telescope discovered about 40 jumbos, wild, free-floating planetary mass binary systems. These jumbos are unlike anything we've ever seen before. Each one has two parts, much like a double planet, with masses ranging from 0.6 to 14 times that of Jupiter. What's truly surprising is that they are not tied to any stars. They are out there on their own. Using the Carl G. Jansky Very Large Array, astronomers detected radio waves coming from one of these systems, showing steady signals from both parts of the binary. This discovery challenges current theories about how such systems could form or stay together. 10. Analyzing star formation in depth ***. Stars are born in dense clouds of gas and dust, but the dust usually blocks most of the visible light, making it hard to see the details. James Webb's infrared radiation cuts through the dust and lets us see deeper into star-forming regions. For example, the telescope captured a frozen-in-time explosion in the Rucci complex, about 390 light-years away, featuring around 50 young stars, many of which are about the same mass as our sun. James Webb has also captured dozens of low-mass stars and the high-speed streams of gas and particles they emit, lighting up surrounding clouds of molecular hydrogen. 11. Circles of the Ring Nebula ***. The Ring Nebula, or M57, is one of the coolest planetary nebulae and is about 2,500 light-years away. The James Webb Telescope has revealed stunning details about this nebula, including about 20,000 clumps of molecular hydrogen in the ring itself. The inner region is filled with superhot gas, and the main shell features a thin ring of carbon-based molecules. The most exciting discovery in the images are 10 concentric arcs beyond the main ring, which astronomers believe were formed when gas from a smaller companion star interacted with the gas ejected by the dying star. 12. Record-breaking distant galaxy ***. In 2023, scientists using James Webb discovered the most distant known galaxy, named JADES GSZ14. This galaxy is shining incredibly bright, which is rare for something so far away. Even more fascinating is that its predecessor, JADES GSD 130, came into existence 320 million years after the Big Bang. But this galaxy is even older and spread over 1,600 light-years across. The light is primarily coming from young stars, rather than a growing supermassive black hole. This galaxy is several hundreds of millions of times the mass of our sun, and the presence of oxygen in the light emissions indicates that multiple generations of massive stars had already lived and died by the time we first observed it. 13. Super-Earth TOI 7115b***. Astronomers discovered a new planet, TOI 7115b, 137 light-years away, that may be just right for life. It orbits a star smaller and cooler than our sun, a red dwarf, which is known for hosting rocky planets. Red dwarfs allow planets to orbit closer to them and still be within the habitable zone, where liquid water could exist. TOI 7115b completes an orbit around its star every 19 days, much faster than Earth's year. This rapid orbit makes it easier to spot planets like TOI 7115b, and scientists suspect there may be other Earth-sized planets in the same system. 14. Ghostly jellyfish ***. One of the most exciting discoveries is a giant jellyfish in space. A strange cosmic structure found by the James Webb Space Telescope shows off a remarkable jellyfish-like shape, with long, flowing tendrils and a glowing core. Astronomers say this cosmic jellyfish is likely the result of a dying star that has ejected gases into space, and the gas is still ionizing from the star's radiation. This is a dramatic and beautiful visualization of stellar death. 15. Exoplanet atmospheres and habitable zones. One of the most exciting aspects of the James Webb Space Telescope's mission is its ability to study the atmospheres of exoplanets in unprecedented detail. By analyzing the infrared spectra of distant planets, astronomers can identify the chemical signatures of key molecules, such as water, carbon dioxide, and methane. These molecules are essential for understanding whether a planet might be capable of supporting life. JWST has already begun studying exoplanets like LHS 475b, a rocky planet located just 41 light-years away, which is similar in size to Earth. This planet's atmosphere is a prime target for investigation because it could offer clues about whether life-supporting conditions exist beyond our solar system. By detecting molecules like oxygen or ozone, astronomers could assess whether an exoplanet falls within the habitable zone, the region around a star where liquid water could exist on the planet's surface. 16. Unusual galactic collisions. The James Webb Space Telescope has also uncovered some unexpected phenomena involving galactic collisions. Traditionally, when two galaxies collide, the intense gravitational forces involved lead to star formation, the merging of black holes, and the distortion of galaxy shapes. However, JWST's observations have revealed that some galactic collisions are much more complex and diverse than initially thought. In one case, two spiral galaxies were found to be colliding in such a way that they formed a double nucleus, two distinct centers of activity, rather than a single merged core. This discovery has led to new theories about how galaxies evolve during collisions and the various stages of galactic mergers that were previously overlooked. 17. The life cycle of stars. Stars go through an incredible life cycle, from their birth in molecular clouds to their ultimate demise. JWST has been pivotal in studying star-forming regions like the Carina Nebula, where young stars are still in the process of being born. The telescope's advanced infrared capabilities have allowed astronomers to peer into the dense gas and dust that conceal newborn stars. For example, JWST has provided insights into protostellar jets, which are streams of gas ejected from forming stars. These jets can sometimes reveal information about the star's environment, such as the magnetic fields around them and the forces that govern their formation. Similarly, JWST has been instrumental in studying the process of stellar death. When massive stars reach the end of their life cycles, they explode as supernovae, enriching the surrounding space with heavy elements. JWST's infrared sensors can detect the shock waves and expanding gas from these stellar explosions, offering new insights into the processes that forge elements like gold, iron, and uranium. 18. The hunt for dark matter. Dark matter, which makes up about 27% of the universe, remains one of the greatest mysteries in cosmology. Although it doesn't emit light or interact with ordinary matter in a detectable way, its presence can be inferred through its gravitational effects on galaxies and galaxy clusters. JWST has been helping researchers track down dark matter by observing galaxy clusters. One key discovery involves using the phenomenon of gravitational lensing, where the light from distant galaxies is bent by the gravity of intervening clusters of dark matter. This allows astronomers to map the distribution of dark matter in greater detail, providing clues about its nature and its role in shaping the universe's large-scale structure. 19. Investigating cosmic inflation. Cosmic inflation refers to the rapid expansion of the universe just moments after the Big Bang. During this period, the universe grew exponentially in size in a fraction of a second. The evidence for inflation comes from the cosmic microwave background, CMB, radiation, But JWST's ability to observe distant galaxies offers a new method for studying this early period in the universe's history. By looking at the oldest and most distant galaxies, JWST may uncover more details about the inflationary period. Some researchers believe that the patterns and alignments of galaxies might provide a more complete picture of how inflation occurred and how it shaped the universe we see today. These observations could lead to breakthroughs in understanding the very beginning of the cosmos. 20. First galaxies and the epoch of reionization. A major milestone in our understanding of the universe is the study of the epoch of reionization, which occurred about 13 billion years ago when the first stars and galaxies began to form. This period marks the transition from an opaque universe to one that became transparent to light. JWST has been observing the earliest galaxies that formed during this epoch, and scientists have already detected galaxies that existed just a few hundred million years after the Big Bang. The light from these galaxies has traveled for billions of years, allowing astronomers to study the very first light in the universe. This discovery is crucial for understanding how the first galaxies began to form and how they influenced the early evolution of the cosmos. 21. The role of black holes in galaxy formation. Supermassive black holes, found at the centers of most galaxies, play an important role in galaxy formation and evolution. JWST has begun to reveal new details about these enigmatic objects, including their role in regulating star formation within galaxies. When supermassive black holes grow too large, they can heat up the surrounding gas, preventing new stars from forming. This process, known as feedback, helps explain why many large galaxies are relatively inactive in terms of star formation. JWST's observations of galaxies in the early universe have allowed astronomers to study how black holes and galaxies co-evolve, providing new insights into the complex relationship between black holes and their host galaxies. 22. The dark side of nebulae. Nebulae, the vast clouds of gas and dust in space, are often thought of as vibrant, colorful structures, but they also harbor some of the darkest and most mysterious regions of the universe. JWST's infrared observations have revealed previously unseen structures within nebulae, such as dense filaments of gas and dust that are invisible in visible light. These structures are important because they provide the raw material from which new stars can form. Some nebulae, like the Eagle Nebula, contain stellar nurseries, where the conditions are perfect for star formation. JWST's ability to see through the dust has enabled astronomers to study these regions in greater detail, providing insights into the early stages of star birth and the complex processes that take place in these cosmic factories.